Welcome to the part 9 of pharmaceutical calculations. In this lecture, I will cover the last topic of isotonic calculations using Sproul's method. Sproul's methods also apply the same principle as in White-Vincent method, where all isotonic solutions added up together, it will form an isotonic solution. However, in this case, let's take one of the ingredients as an example. The adjustment of isotonicity using Sproul's method always based on 0.3 grams of ingredients. So for example, in here you have ingredient A. The V 0.3 grams of ingredient A is equal to 1500 ml. So in this case, it means that 1500 ml of vehicles is needed to make 0.3 gram of ingredient A isotonic. So, and this calculation is proportional. If you have either the volume or the amount of the ingredients is unknown, you can calculate based on this V 0.3. So for example here, if you have 10 mg of ingredient A, how much of the volume you need to make this 10 mg ingredient A isotonic? So you're just taking the basic calculations. 0.3 gram is isotonic in 1500, and with that 10 mg is easy to calculate. It is isotonic in 50 ml. But how are we going to find the V 0.3? Again, is based on the equations developed by White-Vincent. Here, we just substitute the W with 0.3, and you get that V 0.3 gram is equal to 223.3 times E 1%. There are a few references that will give you the list of V 0.3 gram of a certain ingredients, including the active drugs. First, let us look at the very simple example shown here, where you have to just calculate the V 0.3 gram. So in order to calculate that, you will need the value of E 1%. Again, if you are not given E 1%, you should simply calculate it by using the ratio of freezing point depressions of the active ingredients with sodium chloride. So by substituting the E 1% into the equations, you will get 7.7. So again, this 7.7 ml means that 7.7 ml of water or vehicle is needed to produce an isotonic solution containing 0.3 gram of phenolbarbital sodium. So we follow the same example we have from previous methods. So given here again, you have two ingredients available in the system, and potassium chloride is needed to adjust the isotonicity. So here we have provided you the V 0.3 gram of each of the ingredients. Again, I would like to stress on that if this value is not given, you should be able to calculate based on the equation. So for 0.5 gram of phenolbarbital, first we look at the V 0.3 gram of it. So you know that 0.3 gram is needed in 8 ml. So for 0.5 gram, how much of the volume needed to make it isotonic? So it's just a ratio, and very simple, you will get V is about 13 ml. So we'll do the same for 2 gram chlorbutyl, and you will get about 53 ml. So in total, you will have 150 ml. So the rest of the volume should be adjusted by the potassium chloride. So for potassium chloride, the V 0.3 gram is equal to 25.3 ml. So how much you will need to adjust for 83.83 ml? So how much of the potassium chloride you need? So again, it's just a ratio, and you will need about 0.99 gram. So putting all together, you will need 500 milligram or 0.5 gram of phenylpropytone, 2 gram of propytol, and 1 gram of potassium chloride. And this answer again is the same as you using other methods. That's the time we have for Sprowl method for isotonic calculations. Before we end, I would like to stress on again that this method uses the same principle as White-Vincent method. However, the volume given is always referred to the 0.3 gram of the substances.